Morning friends. In the last lecture we have started the HPLC, high performance liquid chromatography. Then in that, first of all, we have seen the definition of this particular technique. Then we have seen the two types of this particular chromatography, normal phase and a reverse phase. Then we come to the instrumentation part. In that we have talked about the solvent reservoir, then the degassive system. Then we have discussed the pumps, three types of the pumps we have seen. That was a reciprocating pump, displacement pump and a pneumatic pump. Out of this, the two will be there. Discuss the pump, different types of the pumps used in the HPLC. That question may comes in the exam. In that you have to draw the diagram and you have to write about this particular pumps. Then we have to talk about the pre-column. Here the diagram of the pre-column is not available, but I will show you that diagram. It is also known as the guard column. Pre-column is also called as the guard column. The function of the pre-column are: number one, to remove impurities in the solvent. Second, to saturate the mobile phase with the liquid stationary phase. The second step prevents the removal of the stationary phase from the packing in the analytical column. This is about the pre-column. Then the sample injection system. In the sample injection system, that sample should be injected into the column by means of a self-sealing Teflon or neoprene septum. Sample can also be introduced by the stop flow method of solvent, remaining the cap on the column and injecting the sample onto the column. The volume of the sample to be introduced is ranging from a few microliters to the 500 microliters. The reproducibility of injections with a typical sampling loop is quite good. This injection system is there. You can see what happens. This is what we can call it. Through this loop that sample is injected. You can see how the opening and the closing is taking place. First of all, we are loading into that particular system, then it will load injecting that sample to the column. This sample loop is there. Okay, at the time of loading and at the time of the injection, that particular shown. Front side view, both has the front side view. How that particular that sample is introduced to the or injected to the column is shown here. Okay, from the pump it comes here, means loading is taking place here, and from this you can see here, from this window it is given to the column. Means you can see here what happens when the sample is loading. In case of the loading, you can see these three are pair, only sample is going inside this. After that, this window close and it will goes to the injected part. Okay, this is about the sample injection system by the means of the self-sealing Teflon or neoprene septum. This is called as a self-sealing Teflon or neoprene septum. You can introduce that sample by the stop flow method of the solvent also, remaining the cap on column, removing the cap on column and injecting the sample onto the column. The volume of the sample to be introduced, that is in the few microliters to the 500 microliters. The reproducibility of the injection with a typical sampling loop is quite good. This sampling loop is used here. In the column, the analytical column consists of the stainless steel tube or double wall glass tube about the 15 to 150 centimeter in length. The column is packed with the particles of diameter 35 to 45 nanometer. What is there? This particular the analytical column consists of the stainless steel tube as a double wall glass tube about 15 to 150 centimeter in length, and the column is packed with particles of diameter 35 to 45 meter. The selection of the column packing depends on the chemical nature of the sample components and the mobile phase to be used. The columns are usually straight, which is surrounded by the water jacket to maintain the constant temperature. This, the sample gets separated on the column due to the partition between the mobile phase and the stationary phase. Of course, that we should know this basically distribution coefficient or the partition coefficient. Then silica, alumina, synthetic resin and ion exchange are used as the column packing. Smaller size column are known as capillary column, having the length about 4 to 5 centimeter, which has 1 to 4 centimeter in internal diameter, and a column packing with a particular size of the 3.5 micrometers. Column is playing the very much important role. They consist of the stainless steel tube or say double wall glass tube about the 15 to 150 centimeter in length, having the variable length. You can use the 30, 40, 50, 60, 70, 80, and that depends. The column is packed with a particles of the diameter of 35 to 45 nanometer. Or say you can use the micrometer also. The selection of the column packing depends on the chemical nature of the sample component and the mobile phase to be used. That whatever the packing material we are going to use in the column, that depends upon the nature of the sample components and the mobile phase. Generally, the silica, alumina, synthetic resin or say ion exchange resins are used as the column packing material. The columns are usually straight, which is surrounded by a water jacket to maintain the constant temperature. The sample gets separated on the column due to partition between the mobile phase and the stationary phase. This is a very important thing, and due to the partition or say distribution of this particular thing, that will separated. Whatever the components are present in the sample, they may be separated on the basis of the partition. How the partition will take place, some will retain on the stationary phase and someone will exchange with the mobile phase. That is a very much important thing. Okay, while studying this particular part, what we have to remember, the partition will be there, and due to this partition the separation is possible. Similar size, smaller size of the column are known as the capillary column, having the length about 4 to 5 centimeter and 1 to 4 centimeter in internal diameter, and the column packing with particular size of 3 to 5 3.5 micrometer. Okay, then we will talk about that detector. What are the requirements of the good detector? Sometimes that question will be there, which say we can say which properties should have to fulfill by the good detector or the role of detector. That question will come in the exam. Sometime that question comes. Detector should be sensitive to the tune of detecting and measuring the amount of solid, sensitive to the tune of detecting and measuring the amount of solid in range of 10 raised to minus 8 or even less. For a very low concentration, it has to detect. That is a very highly sensitive detector should be there. The response of the detector should be linear, covering concentration over several orders of magnitude. The response time should be as small as possible. It should have to possess high degree of reliability and ease of operation. Detectors should have similar response to all type of solute. It should be stable to detect the solute. It should be able to detect the solute without destroying the sample. These are the few advantages of this particular detectors. What is the first advantage of this detector? Detector should be sensitive to the tin of the detecting and measuring the amount of the solid in the range of 10 raised to minus 8 gram or even less. Then the response of the detector should be linear, covering the concentration over the several orders of the magnitude. The response time should be as small as possible, and detector has to possess that particular high degree of the reliability and ease of operation. It should be have similar response to all type of the solid. Should be stable to detect the solid. Should be able to detect the solid without destroying the sample. These are the characteristics of the good detector that you have to write in the exam. Sometimes the question comes 5 point you have to write in the particular heading. You have to write this well. This is about HPLC. We have seen this particular part, instrumentation. Please read that part well. Reading is very much important. If you not read it properly, then it is very difficult to understand. Okay, please prepare this part well. Please continuously read this part. In this particular instrumentation of this HPLC, we have talked about basically the different components, that is solvent reservoir. We have talked about the solvent reservoir which can store the sample, which may be the made up of the glass or stainless steel, having the capacity 1 to 2 dmq, or say you can call it as 1 to 2 liter of the solvent. Degaseous system, we have seen that the role of main purpose of this degaseous system is to remove the dissolved gases like the oxygen, nitrogen from the solvent. It can be done by the vacuum pumping system, distillation system, or say spraying. Then the requirement of the pump is there. Should generate a pressure of about 6000 psi. Should have to provide flow rate ranging from 0.1 ml to 10 ml per minute. The flow of liquid should be smooth and continuous. It should not occur in the form of pulse. Means pulse should not be produced. Pump should have to provide reproducible rates to the extent of the 0.5% or less. There are the three type of the different pumps that we have seen: reciprocating pump, displacement pump, and the pneumatic pump. That reciprocating pump we have seen, it consists of the small chamber in which the solvent is pumped by the back and the forth movement of the motor driven piston, you can see here. Then it consists of the two ball bearing check valves which open and close alternatively, controls the flow of solvent. Here two balls are there, you can see, which can control the flow of the solvent. solvent is in the direct contact with the piston. Advantages: small volume of the solvent is used. The pressure developed can be order of the 10,000 psi. It gives a constant flow rates independent of the solvent viscosity and a column pack pressure. It can be readily adapted to gradient elevation technique. Disadvantage: it is not a pulse free. Displacement pump we have seen. It consists of the large syringe-like chamber equipped with the plunger, or that is activated by the motor driven screw mechanism. It also produces a flow which tends to independent of the viscosity and back that particular back pressure of the column, and it is a pulse free. This is advantage. Disadvantage is that limited solvent capacity and inconvenience when the solvent must be changed. Pneumatic pumps: the mobile phase is placed in the collapsible container housed in the vessel that can be pressured by the compressed gas. The pumps are inexpensive and pulse free. Disadvantage is that they have limited capacity and pressure output as well as depends on the flow rate of the solvent, viscosity and the column pack pressure. It is not used in case of the gradient dilution. It produces the pressure of the order of 2000 psi. Pre-columns we have seen, it is also called as the guard columns. The role of this pre-column is to remove the impurities in the solvent and to saturate the mobile phase with the liquid stationary phase. And second step prevents the removal of the stationary phase from the packing in the analytical column. Then the sample injection system we have seen, this sample loop is there through which the sample is loaded on the column or say injected or say introduced to the column. Then the column, about the column we have seen, it is generally made by the stainless steel or say double wall glass tube. Length is, you should know the length. Then packing material: silica, alumina, synthetic resin or ion exchange resin can be used as the column packing material. Then we talk about the detectors, the characteristics of the detector or the requirement of the good detectors that we have seen. Please go through this part, please prepare it well. If you are not getting any part, you can ask. Here we will stop. Thank you.